All right, so NVIDIA CEO Jensen Huang just laid out what's next for computing itself. And it's huge. We're going to break down his entire vision and really dig into how it's about to redefine not just our tech, but pretty much our entire world. So let's kick things off with this really powerful idea from Jensen himself. Every 10 to 15 years, the computer industry resets. Now think about that for a second. He's saying we're not just living through another one of those moments, we're right in the middle of one of the biggest resets in the history of technology. Period. I mean, just look at the history, right? We had the mainframe era, then came the PC revolution, the internet connected everything, which led to the cloud, and then mobile put all that power right in our pockets. Every single one of those was a massive, industry-shaking platform shift. But here's the kicker. AI isn't just the next domino to fall. It's a completely new layer that's about to redefine everything that came before it. Okay, so here's how we're going to break this all down. First, we'll look at this huge AI platform shift. Then we'll get into AI that can actually think. We're talking agents. After that, we'll see how it's moving into the physical world. We'll check out the engine, Vera Rubin, that's powering it all, and wrap up with what this new era really means for everyone. Let's get into it. All right, first step. The AI platform shift. And what's really wild about this moment is that it's not just one big shift. It's actually two happening at the same time. It's not just about what we're building, it's a complete teardown and rebuild of how we build it and how we run it. And this slide just lays it out so clearly. The old way? You meticulously programmed software line by line, and it ran on CPUs. The new way? We're not programming, we're training software, and it runs on GPUs. This means our applications are no longer static, precompiled things. They're alive, they're generative, they create brand new stuff right on the fly. So you might be wondering, where is all the money for this massive revolution coming from? Well, here's your answer. A mind-blowing $100 trillion. That's the value of global R&D budgets that are now being completely rerouted, basically funneled away from the old ways and poured directly into artificial intelligence. This isn't a small shift, folks. It's a full-blown economic migration. Okay, so what does this new kind of computing actually look like in practice? Well, we're seeing this incredible evolution, this jump from AI that, sometimes just makes stuff up, what we call hallucination, to an AI that can actually genuinely reason its way through a problem. And this incredible leap, it's all powered by something called Agentic systems. Think about it this way. A chatbot just kind of responds to what you say. An agent, on the other hand, can actively go out and solve problems it has never, ever been specifically trained for. It figures it out by reasoning, by using tools, and by making a plan. A lot like we do. So how does an agent actually pull this off? Well, when you give it a really complex task, it doesn't just guess or throw a random answer at you. No, it's systematic. First, it breaks the problem down into smaller pieces. Then it figures out what tools it needs, maybe it does some research, and only then does it put together a concrete step-by-step plan to get the job done. And this is a really crucial point. We're not talking about some single, giant, all-knowing AI brain. The modern AI framework is more like a super smart team. It's multimodal, meaning it can see, hear, and read. It's multi-model, so it can call in other specialist AIs when it needs help. And it's multi-cloud, so it's not stuck in one place. It can operate everywhere, from a massive data center all the way to the device in your hand. Okay, so we've got an AI that can reason. That's amazing. But here's where things get really interesting. The next frontier is taking that intelligence out of the computer and putting it right here into our physical world. We're talking about teaching AI the basic, common-sense laws of physics. And that brings us to physical AI. For something like a robot or a self-driving car to actually work safely, it's not enough for it to understand language. It has to get physics. It needs to know that if you drop something, it falls, that a big truck can't stop on a dime. It needs that fundamental common-sense grasp of how the real world actually works. But that raises a huge question. How on earth do you teach an AI all of that? I mean, you can't just go out and record videos of every possible thing that could ever happen in the physical world. It's impossible. The amount of data you need is just infinite, not to mention how expensive it would be to even try. And the solution is just brilliant. If you can't record the real world, you create a perfect digital copy of it. You simulate it. NVIDIA is literally turning pure compute power into data using this incredible world foundation model called Cosmos. Basically, it's an AI that dreams up an endless stream of physically accurate situations for other AIs to train on. It's a virtual playground for learning. And the perfect example of this in action is Alpamo. This is NVIDIA's autonomous vehicle AI. It doesn't just learn from watching humans drive. It learns from millions, maybe billions of simulated miles inside Cosmos. And that's the key. It allows the AI to learn how to handle incredibly dangerous situations without ever having to face them in the real world first. So, you've got these thinking agents, you've got this physical AI, but all of this requires a level of computational horsepower that is just off the charts. It's more than anything we have today. So let's look under the hood at the brand new engine that's going to drive this whole revolution. Because this future needs a completely new kind of computer. And here's the massive challenge we're up against. Insane, exponential growth. The AI models, they're getting 10 times bigger every single year. And the amount of stuff they're generating, the tokens, is growing 5 times bigger. The demand is just exploding. And the honest truth is, the computers we have today just can't keep up with that pace. The answer to that problem? It's called Vera Rubin. And let's be clear, this is not just a faster chip. It is an entire supercomputer platform. To get the kind of performance leap they needed, NVIDIA basically had to throw out the old playbook and redesign every single component in the system from scratch, all at once. It's an absolutely massive undertaking. And when you look at this, you're not just seeing a list of computer parts. This is a complete ecosystem where every single piece was designed to work in perfect harmony with every other piece. You've got the new Vera CPU, the Rubin GPU, and all these custom chips for networking and data. By co-designing the whole shebang, they've built something that acts less like a collection of parts and more like one single, unified, incredibly powerful brain. So what's the payoff for all that hard work? It's right here. To train one of these huge frontier AI models on the last generation of hardware, you're looking at about a month. With Rubin, it's down to 1 week. That's not just a little faster. That is a fundamental acceleration of the pace of innovation itself. It's a total game changer. Okay, so let's put all the pieces together. You have these massive breakthroughs in software, in hardware, and in how they talk to each other. What does it all mean? It means we are standing right at the dawn of a completely new era of computing. When you boil it all down, it's really a 3-part revolution. Pillar 1, Agentic AI. This is software that can actually think, reason, and make plans. Pillar 2, Physical AI. These are intelligent systems that can understand and operate in the real world. And Pillar 3, Accelerated Computing. That's the Vera Rubin engine, the raw power that makes the first 2 pillars possible. And all of this leaves us with one final and pretty profound question. For the very first time in history, we've created an intelligence that doesn't just understand our words. It's starting to understand the physical laws of our universe. So now that AI can both simulate our world and interact with it, what are we going to ask it to build next?